Hello, my name is Robert Smith and I'm with New River Community College, and today we're looking at the entropy change in phase transitions. In this case, we're looking at water going from a solid to a liquid and then from a liquid to a gas. These are the kinds of steps that you'll need to do. You'll need to calculate on a test or quiz or homework. And whenever they're asking for the change in entropy for a phase transition, you can expect to perform this exact same calculation. And what we're looking at specifically is how does it change as we're going from solid to liquid or from liquid to gas. Mind you, if we're going the opposite direction, you would have to work with the sign difference. But we're provided the molar heat of fusion, so delta H of fusion, call that delta H of fuse, is equal to 6.02 times 10 to the third joules per mole. And delta H of vaporization, is equal to 40.7 times 10 to the third joules per mole. The reason I'm writing them in terms of joules per mole is because we're asked to calculate entropy. And eventually you're going to have to get that entropy down to joules per mole Kelvin. You can't just take it as kilojoules per mole Kelvin. That's not the proper unit for entropy in this case. So what is the formula for entropy? It's entropy is going to be delta S is equal to delta H over T in this case. This is a variant on the second law of thermodynamics. So in this case, we're looking for delta S of fusion. Going from ice to liquid water is going to be 6.02 times 10 to the third joules per mole over the temperature at which water freezes, which in this case is 0 degrees Celsius, but we want it in Kelvin, which is fortunate because dividing by 0 would not yield the result that we want. So in Kelvin, it's 273 K. And that gives us a change in entropy of 22.1 joules per mole Kelvin. And you'd expect it to be positive because you're increasing the number of microstates as you transition from a solid to a liquid. And similarly, as you transition from a liquid to a gas, the number of microstates will increase. So again, we're looking at a positive figure, and 40.7 times 10 to the third joules per mole over the boiling temperature of water, which would be 100 degrees Celsius or 373 K. And that gives us 109 joules per mole K, which again is positive, and it is larger than the delta S of fusion, which is what you would expect as well, because the number of microstates increase significantly as you transition from water, liquid water to water vapor. So